Good evening, children. Good evening.
Good evening.
Good evening. So last class, I think we finished 1, 2, 3, and the fourth one I had asked you to complete. Let me explain that now. So we'll quickly recall what we understood. This first question, am I using the right presentation, children? This one, right?
Yes, ma'am.
All right. Yeah. Let's quickly recall how we work this. So in this one, you can see that the question is evaluate. That is find the value of this expression. Find the value of this expression. So what is it important thing that you have to observe? Look at the angles. The angles are all standard angles. 30 degrees, 45 degrees, 60, 45, 60, 30, all standard angles. That means you can get the values from the table. You have a table of trigonometric ratios of standard angles. So from that table, you can get the values of these trigonometric ratios. So you just have to get the values from the table, simplify, and what happened was that the denominator was irrational. After simplifying, this is what we got. We got this after simplifying, but the denominator is irrational, 3 root 3 plus 4. And we know that we should not leave the answer with an irrational denominator. So like what we have learned in 9th standard, we go ahead, we find the conjugate of the denominator. The denominator is 3 root 3 plus 4. Its conjugate is 3 root 3 minus 4. The denominator is, this is what you get when you simplify this. See, this gets cancelled and the answer is 3 root 3 minus 4 by this 3 root 3 plus 4. This is the answer. It ends here. But we observe that the denominator is irrational. So we proceed to rationalize it. The conjugate of the denominator is 3 root 3 minus 4 because it's plus here. It's plus here, so 3 root 3 minus 4. So we multiply and divide by 3 root 3 minus 4. And then you know how to proceed. The numerator in both the places is like a minus b into a minus b. 3 root 3 minus 4 into 3 root 3 minus 4. So it's 3 root 3 minus 4 to the whole square. A minus b into a minus b the whole square. Denominators like a plus b into a minus b. A plus b into a minus b. So a squared minus b squared. A squared minus b squared. A squared minus b squared. Algebraic identities. And then, you know, a minus b the whole square is a square minus 2ab plus b square. So simplify and you see that the final answer has a rational denominator. The final answer has a rational denominator. So here the angles are standard angles. So it's very easy. Just get the values from the table and simplify. In the next one, we were given that 5 cosecant theta. 5 cosecant theta is equal to 7. So we need to work this. Cosecant theta is equal to 7 by 5. And I've told you that when you have the value of one trigonometric ratio, you can find the values of the other trigonometric ratios very easily using a right triangle. So just mark off any one angle as theta. And what is cosecant theta? Is hypotenuse by opposite. Cosecant is hypotenuse by opposite. So 7 you should take for the hypotenuse. And opposite of theta is 5. Find the side using Pythagoras theorem. And since we know that cosecant theta is 7 by 5, Sine theta is easy, 5 by 7. Sine theta is 5 by 7. Cosecant theta is 7 by 5. Its reciprocal sine theta will be 5 by 7. So 5 by 7 we got. And then cos theta you can find using the triangle. Using the triangle, opposite by hypotenuse will give you cos theta and hence find cos square theta. So to evaluate this expression, we only need the value of cos theta because sine theta we already have. Cosecant theta is 7 by 5. Its reciprocal sine theta will be 5 by 7. Cos theta can be found using the right triangle. And cos square theta, square it, cos square theta minus 1. So simply substitute the values of sine theta and cos square theta and you get the answer. We also did a different way in the class. But this is the general thing. When you're given one T ratio, you can find the values of the other T ratios using a right triangle. You can also find using trigonometric identities. Now in this question, we are given that sine A is equal to root 3 by 2. Root 3 by 2. If you have memorized the table, it will occur to you that this value root 3 by 2 is found in the sine table. Sine of which angle is root 3 by 2? Sine 60 degrees. Sine 60 degrees is root 3 by 2. So sine A is equal to sine 60 degrees. Root 3 by 2 can be replaced with sine 60 degrees because the value of sine 60 degrees is root 3 by 2. Is root 3 by 2. So instead of root 3 by 2, you can write sine 60. See, I've told you this. You can always, given one the value of one trigonometric ratio, you can find the values of the other trigonometric ratios using a right triangle, using trigonometric identities. Apart from that, in this situation, you can also do this. That's always there. Not that here you should not use a right triangle or you should not use trigonometric identities. With this information, you can also use this method. What is that? Since this value root 3 by 2, you can see it in the sine table, and you know that sine 60 degrees is root 3 by 2. Take away root 3 by 2 and replace it with sine 60 degrees. On comparing both the sides, A is equal to 60 degrees. A is equal to 60 degrees. On comparing both the sides, A is 60 degrees. Now what? We have to evaluate 2 cot square A minus 1. So that means 2 cot square. We found the value of A, 60 degrees minus 1. And find the value of cot 60 from the table. See, cot 60 degrees, when you square it, it's written as cot square 60 degrees. You cannot square the angle. Don't write cot, it's not cot 60 degrees, the whole square is not cot 3600. Cot 60 degrees, the whole square is cot 60 into cot 60. Cot 60 into cot 60, which is written as cot square 60 degrees. So you should find the value of cot 60 from the table and square it. Write the value of cot 60 and square it. And simplify. Please tell me the two, algebraic identities involving A plus B and A minus B. Yeah, Rajeshwari is ready. Yes?
Ma'am, A plus B the whole square plus A minus B the whole square is equal to 2 into A square plus B square.
Very good. So this is Nandini. A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. Very important identity. And what's the other one? Plus? What's the other one?
A plus B whole square minus A minus B whole square is equal to 4AB.
4AB is equal to 4AB. So here in these algebraic identities, you can use A as sine theta and B as cos theta and rewrite the identities to look like trigonometric identities. the variables a and b. Now these are algebraic identities because you can see the variables a and b. Now instead of a, you can use sine theta when you use sine theta, and for b when you use cos theta. You can convert this algebraic identity to a trigonometric identity. And again, these identities, when converted as trigonometric identities, are very useful. And that is what we use to solve the first one. This one, 3a. 3a. How is it? We are given the value of sine theta minus cos theta. And we have to find the value of sine theta plus cos theta. Like we are given the value of a minus b. And we have to find the value of a plus b. It's like you're given the value of a minus b, sine theta minus cos theta. And you have to find the value of a plus b, sine theta plus cos theta. So let's make use of that identity. So we write sine theta plus cos theta, the whole square, plus sine theta minus cos theta, the whole square, is equal to 2 of a square minus b square, sine square theta plus cos square theta. Very important identity. Yeah, class, use the emoji, raise your hand. Kanishka, Nandini, Ramanathan, Priyanka, Rajeshwari, Rajarajeshwari, Murali Krishna, Sneha, Harini, Ananya, Netra. All right. Okay, so this identity is very important, children. All of us get this? So we have three expressions, sine theta plus cos theta, sine theta minus cos theta, sine square theta plus cos square theta. Now we know that sine square theta plus cos square theta is 1 identity. It's 1. Sine theta minus cos theta is 1 by 2. So we can find this third one. We can work this and find the third one. Always, when there are 3 unknowns and 2 of them are given to you, you can find the third one. In an equation, if you have, say, 7 unknowns, in an equation, you have 7 things not known. And of the 7 unknowns, if you're given the value of 6 of them, you can find the 7th one. So here in this identity, we have 3 different expressions: sine theta plus cos theta, sine theta minus cos theta, and sine square theta plus cos square theta. Now this is 1 identity, this is 1, and this one is given 1 by 2. So of the 3 expressions, we know the values of 2 of them. So you can find the third one. So that's how this is. And this I told you, you will have to convert this to a quadratic equation in x by replacing cot theta with x. So it will be root 3x square minus 4x plus root 3 is equal to 0. In place of cot theta, use x. In place of cot theta, use x. And rewrite the equation using x. So now it's a quadratic equation in x. Split the middle term. Find the 2 values of x. And the 2 values of x will be the 2 values of cot theta, because cot theta's x is what we have assumed. So the 2 values of x will be the 2 values of cot theta. So using them, you can find theta and hence evaluate cot square theta plus tan square theta. See, the strategy to remember, see, it depends, different things we remember in different ways. Now, when it comes to trigonometry, understand the information given in the question, and you should be able to now whatever I'm explaining now, what did I say? When we look at this, we need to replace cot theta with x and convert this one to a quadratic equation in x. Then split the middle term, solve it, find the 2 values of x. The 2 values of x will be the 2 values of cot theta. Like that, we'll find the value of theta. We'll find the value of theta. And once you get the value of theta, you can evaluate cot square theta. Now you say, I don't know what we got. We got 30 and 60. Okay. So we got 30 and 60. So theta, when theta is 30 degrees, it will be cot square 30 degrees plus tan square 30 degrees. And when theta is 60 degrees, it will be cot square 60 degrees plus tan square 60 degrees. This is what you'll have to find. Simple. So there's actually, you work it once and you may have to work it again. Then every time you revise, it's not possible to work everything. Every time you revise, it's time consuming. You cannot really work out everything. So you should be able to look at the question and, talk about or say about how the answer will go. It should be like a question answer session. You should be able to tell in words. Regarding the flow of the answer. How the answer goes, you should be able to remember in words. So the situation, cot theta is x, then quadratic equation, solve for x. The two values of x are the two values of cot theta. Using that, you can find theta. And once you find theta, you can evaluate cot square theta plus tan square theta. Yeah, we need to continue from here. I don't know. All of you finished writing this, children? Okay, if you have not, you can write it now in the class. This one alone, I had asked you to complete. This one alone, the others we had, worked out in the class itself. Now in this question, if sine A is equal to 1 by root 5, it's not a standard value. You don't find 1 by root 5 in the table. So you cannot find angle A. And if sine B is equal to 1 by root 10, again, you cannot find 1 by root 10 in the table. Okay, if sine A is equal to 1 by root 5 and sine B is equal to 1 by root 10, find the values of cos A and cos B. Hence, using the formula, this is the formula which is given to you. Using this formula, cos of A plus B is equal to cos A cos B minus sin A sin B. Find A plus B. Find A plus B. So let's first answer the first part of the question. Find the values of cos A and cos B. Find cos A and cos B. So we'll find cos A using sin A. We'll find cos B using sin B. We'll find cos A using sin A. We'll find cos B using sin B. Okay. So we know that sine square theta, or here sine square A, okay, plus cos square A is equal to 1. Let me write it here. Sine square A plus cos square A is equal to 1. We know this. Now you can substitute here itself, children. Not that you should. Just 1 minute. 1 minute. So sine square A plus cos square A is equal to 1. You can substitute here itself, children. Not that you must write cos A is equal to root of 1 minus sine square A. You can substitute here itself. So what is sine square A? What is sine A? 1 by root 5. So what is sine square A? Square it. Square this. Sine square A is nothing but sine A the whole square. Sine square A is nothing but sine A the whole square. The value of sine A is 1 by root 5. So sine A the whole square will be 1 by root 5 the whole square plus cos square A. That's what we have to find. Cos square A is equal to 1. You can work it like this. Then you can take this 1 by root 5 the whole square to the other side and do it. I hope you're all following this. You can write this identity, substitute here, transpose and find the value of cos A. That's what I've done here. I've written this straight away. What have I written? I've written sine square A plus meaning I've used sine square A plus cos square A is 1. And from this cos square A is equal to 1 minus sine square A. Please listen carefully. So cos A is equal to root of 1 minus sine square A. See, this I've already explained in the videos. Okay. Some other interpretations of the trigonometric identities. Interpretations of the three main trigonometric identities. There, this is explained to you in the YouTube videos, not in the meeting recordings. Interpretations of the three trigonometric identities. From the main three identities, we can get many other versions. So one of it is this, cos A is equal to root of 1 minus sine square A. You can write this straight away. Or you can write the identity sine square A plus cos square A is 1 and substitute here itself. And find cos A. What is your intention? Find cos A, that's all. So I have written cos A is equal to root of 1 minus sine square A and I've substituted like this. Sine A is 1 by root 5. See, I told you, find cos A using sine A. Find cos B using sine B. Okay. So this working, you understand LCM and all that, root 4 by 5, which is 2 by root 5. Cos A is equal to 2 by root 5 because root 4 is 2 and root 5 is root 5. Similarly here, cos B using sine B. So how do you write the identity? Sine square B plus cos square B is equal to 1. Sine square B plus cos square B is equal to 1. So you can substitute here and get cos B. I have written this. Cos B is equal to root of, because cos square B is equal to 1 minus sine square B. So cos B is equal to root of 1 minus sine square B. I've written that and substituted the value of sine B, 1 by root 10, the whole square. So 1 by root 10, the whole square is 1 by 10. 1 minus 1 by 10, 9 by 10 after LCM. And root 9 is 3, root 10. So we found cos A using the value of sine A. And we found cos B using the value of sine B and using the relevant identities. Sine square A plus cos square A is equal to 1. See, sine square A plus cos square B is not 1. Cos square B is not 1. If the sine square A, cos square A, the angle should be the same. If you say sine square B, then cos square B. So like this, find cos A and cos B. Now we have answered the first part. Find cos A and cos B, we found. Next, we have to find the value of A plus B using this formula. This formula is given to us. Using this, we'll have to find the value of A plus B. So write the formula. Cos of A plus B is equal to cos A cos B minus sin A sin B. That's given to us. Write that. All right. Now we know the values. We know all the values. Write this cos A plus B, cos of A plus B as it is. We know that cos A is 2 by root 5. Where is it? Cos A is equal to 2 by root 5 here. And what is cos B? Cos B, we know that it is 3 by root 10. So substitute. Cos A, cos B meaning cos A into cos B. Minus sin A. It's here. Sin A is here. 1 by root 5. Into sin B is here. 1 by root 10. So multiply the numerators. 2 3s are 6. 2 3s are 6. Root 5 into root 10 is root 50. 1 1s are 1 or 1 is 1. And root 5 into root 10 is root 50. Sorry. Root 5 into root 10 is root 50. Common denominator root 50. 6 minus 1 is 5. 5 by root 50. Root 50 is a pure surd here. You can write it as a mixed surd. How? So 50, 225 times 5, 5s are 5 1s are. So root 50 is equal to root 2 into 5 into 5. 50 is equal to 2 into 2 into 5. 50 is equal to 2 into 2 into 5. Root 50 is root 2 into 5. Oh my God. 2 into 5 into 5. 50 is equal to 2 into 5 into 5. Root 50 is equal to root of 2 into 5 into 5. So from 2 5s, 1 5 comes out. 5 root 2. So root 50 is equal to 5 root 2. I think I was fast. 1 minute. 50, 2, 25, 5, 5, 5, 1. 50 is equal to 2 into 5 into 5. Next step. Square root of 50 is equal to square root of 2 into 5 into 5. Taking square root on both the sides. Square root of 50 is equal to, from 2 5s, 1 5 comes out. And 2 remains under the square root. So square root of 50 is nothing but 5 root 2. That's what it is, 5 root 2. Then what happens? 5 and 5 gets cancelled. 5 gets cancelled. So 1 by root 2. 1 by root 2. Now, where is 1 by root 2 in the cos table? Where is 1 by root 2 in the cos table? Cos 45 degrees is equal to 1 by root 2. Cos 45 degrees is equal to 1 by root 2. Okay. So 1 by root 2, instead of 1 by root 2, in the next step we say cos 45. Instead of 1 by root 2, in the next step we say cos 45. On comparing both the sides, a plus b is equal to 45 degrees. On comparing both the sides, a plus b is equal to 45 degrees. How many of you already wrote this, completed this in your classwork?
B, ma'am.
Okay. Who else?
I too completed it, ma'am.
Very good. Others? Rajarajeshwari, Priyanka, Murali, Kanishka?
I have not completed it.
No?
Completed it, ma'am.
Okay. You already have the screenshot. So if you have not completed, leave some place and complete it later. Yeah, this we'll do not now because we haven't started identities, proving identities. So we'll not do this now. So that's all in this presentation. Yeah. So see this, evaluate, look at the angles, children. Is there any standard angle in the expression? Is there any standard angle in the expression?
Sine square 45 degrees.
Sine square 45 degrees. So 45, that's the only standard angle. The others are not. So when the angles are not standard angles, we mostly make use of the trigonometric ratios of complementary angles. First, you need to plan. We cannot just start working like that. See, what do I mean by that? See, when you're given something like 3 by 7 minus 1 by 4 plus 1 by 28, you cannot plan all the steps. So when you look at this, you know, okay, I have to take the LCM of 7, 4 and 28. That's all you plan. Then once you do that step, then next step you add or subtract. So one step will tell you what you, the previous step tells you what you should do in the next step. But here it's not like that. You must plan the whole thing. So look at the given expression carefully and decide what you have to do with it. Now this one, secant square 54 minus cot square 36. Now tell me some identity relevant to this. See, children, I want you to do this because you have to participate. Otherwise, it's so difficult for me to understand if you're following or not. Now, what you do is you should have memorized, all the details in the introduction. In case you haven't, you please make a chart. What should the chart have? See, take a big piece of paper, a long rule sheet, Please do this, keep this ready by the next class. Keep this ready by the next class. In that, write out the first part. Sine, what is that? Sine theta is equal to opposite by adjacent. Cos theta is equal to, oh my God, opposite by hypotenuse. Cos theta is equal to adjacent by hypotenuse. Tan theta is equal to opposite by adjacent. Then cosecant theta. I think I'll write it now for you. 1 minute. Yeah, all of you, if you have a long sheet or if you're using a long notebook, write down behind. You pull out, all of you take a sheet. So that you can keep that beside you and at least refer where I'm asking you. Sine theta is equal to opposite by hypotenuse. Cos theta is equal to adjacent by hypotenuse. Tan theta is equal to opposite by adjacent. Cosecant theta is the reciprocal of sine theta. 1 by sine theta. It's hypotenuse by opposite. Secant theta is a reciprocal of cos theta. That is hypotenuse by adjacent. And cot theta is the reciprocal of tan theta is equal to adjacent by opposite. Sine theta is 1 by cosecant theta. 1 by cosecant, and cosecant theta is 1 by sine theta. Cosecant theta is 1 by sine theta. Similarly, cos theta is 1 by secant theta. Secant theta is 1 by cos theta. Tan theta is 1 by cot theta. And cot theta is equal to 1 by tan theta. And cot, very important, tan theta and cot theta. Tan theta is also sine theta by cos theta. Sine theta by cos theta. And cot theta is cos theta by sine theta. Write down all of you quickly. At least refer and let me know the answer. Fast. Done, children?
1 minute.
Yeah.
Yes, ma'am.
Okay. Yeah. Yes, it's time, children. Finished?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. The next thing is about this is, one part of trigonometry. Then the other is about the trigonometric identities. Remember like this, Sine square theta plus cos square theta is equal to 1. Now from this you can get the others. Then secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. These three identities. Write down. The table containing the values that I'm not writing now. That's the third part. So one is the basic thing about the 6 ratios and how they connect the sides in a right triangle, opposite side by hypotenuse, how they connect the sides in a right triangle. So there we also see the reciprocal ratios. In the first part, we also see the reciprocal ratios. Sine, cosecant, secant, cos, tan and cot. The second part is about the identities. Then the third part, the table containing the values of some standard trigonometric ratios. Yeah. Then the fourth part, complementary angles, trigonometric ratios of complementary angles, the fourth part. So these are the 4 different, aspects we have learned so far. And that's all you have for this year. So one is about the basic ratios, sine, cos, tan, and their reciprocals, cosecant, secant, and cot. Then, so when it's sine theta, the ratio of the sides it connects. So sine theta connects the opposite and hypotenuse, like that, all that. And then, this is very important, that tan theta is sine theta by cos theta, cot theta is cos theta by sine theta, very important. Next, trigonometric identities. And what is important, the first part is sine theta can be replaced with 1 by cosecant theta. Cosecant theta can be replaced with 1 by sine theta. Cot theta can be replaced with 1 by tan theta. And tan theta can be replaced with 1 by cot theta. So that's about the first part. Then the trigonometric identities. Then the values, the table that I'm not writing now. Then the last part, trigonometric ratios of complementary angles. So there it is like this. Sine theta is equal to cos 90 minus theta. Cos theta is equal to sine 90 minus theta. Sine 90 minus theta. Secant theta is equal to cosecant 90 minus theta. Cosecant theta is equal to secant 90 minus theta. Tan theta is equal to cot 90 minus theta. Cot theta is equal to tan 90 minus theta. That's all. That's all. This much you write on a long rule sheet, have it beside you. Don't say that you did not memorize because you always made us refer the paper. So I didn't memorize at all. I've been using the paper always. Don't blame me for that. You have to memorize. So since you're not responding, I just want you to have this paper beside you. You can at least refer an answer. Yeah. All right, over. Yes, done. Yeah, good. Now, children, look at this. Secant square 54 minus cot square 36. You can see the square there, secant square, cot square. Now just tell me, you can relate this with what? Whatever occurs to you. You want to make this look like what? Secant square. Do you think you should use complementary ratios or trigonometric identity? What comes to your mind? Okay, so difficult to answer. No problem. I'll help you with this. So when you look at the secant square 54 minus cot square 36, you must either, think of converting this to secant square 54 minus tan square 54. Or you must try to write it as cosecant square 36 minus cot square 36. I'll write both the ways. 1 minute, 1 minute. Let me write this like this: secant square 54 minus cot square 36. So for me, I feel we can make use of the identity, like secant square theta minus tan square theta is 1. So what is it here? Secant square 54. Secant square 54. So that means I should get tan square 54. Then only I can write it as 1. Secant square theta minus tan square theta is 1, which means secant square 54 minus tan square 54 will be 1. So you want it to either look like this, or here we have cot square 36. So you want it to be cosecant square 36 minus cot square 36, so that you can make it 1. Cosecant square 36 minus cot square 36 is 1. Now tell me if I'm clear. You must think of converting secant square 54 minus cot square 36 to one of these two. Any one of these two, both will be right. If you take secant square 54, then you want tan square 54. If you take cot square 36, then you want cosecant square 36. These are two different identities. This one is, the first one is secant square theta minus tan square theta, which is 1. This one is cosecant square theta minus cot square theta, which is 1. Now tell me for the denominator. You can do any one of the two. Any one of the two you can do. Now tell me for the denominator, children. Cosecant square 57 minus tan square 33. What are the two ways of converting it? Yes, fast. So in one you want cosecant square 57. In the other you want tan square 33. Then if it is cosecant square 57, what is the other one you want?
Cot square 57, ma'am.
Yeah. Minus cot square 57. Cosecant square theta minus cot square theta. So that means you should change this tan square 33 to cot square 57. Or if you want tan square 33, you need secant square 33. That means you must change cosecant square 57 to secant square 33. So the thing is, you need to convert the numerator and the denominator to suit, the relevant identity. You fix the identity. You want it to look like which identity, you fix that. And you do the necessary changes. So now if you want secant square 54 minus cot square 36 to look like secant square theta minus tan square theta, so what should you do? Write secant square 54 as it is. Minus, you want to change this one. So now this is first cot square theta. Cot square theta is nothing but tan square 90 minus theta, because cot theta, look into the paper, cot theta is tan 90 minus theta. Cot theta is tan 90 minus theta. So cot square theta, when you square on both the sides, cot square theta is tan square 90 minus theta. Tan square 90 minus theta, when you square it on both the sides. I've told you this. Cot theta is tan 90 minus theta. When you square this on both the sides, you get cot square theta is equal to tan square 90 minus theta. So cot square 36. Cot square 36 is tan square 90 minus 36. Tan square 90 minus 36. See, I'm using this. Cot square theta is equal to tan square 90 minus theta. So cot square 36 is tan square 90 minus 36. So that is secant square 54 minus tan square 90 minus 36 is 54. So secant square theta minus tan square theta is 1. Or what you can do is you can take secant square 54 minus cot square 36 and change secant square 54. Change secant square 54. And you can change secant square 54. How? What is secant theta? Secant theta is equal to cosecant 90 minus theta. Secant theta is equal to cosecant 90 minus theta. So secant square theta will be equal to cosecant square 90 minus theta. So you have secant square theta. So you can write it as cosecant square. You can write as cosecant square 90 minus theta. 90 minus theta is 54. You change this one. No, don't change this. Write that as it is. Change any one of the two. Don't change both. So that will be cosecant square 90 minus 54 is 36 minus cot square 36. So see here, cosecant square 36 minus cot square 36, which is 1. Because cosecant square theta minus cot square theta is 1. Similarly, you should work with the denominator. Then here in this part, this part, sine square 45 is not a problem because you can get the value from the table. So we have to decide about how to handle sine square 38 and secant square 52. Here identity will not help you because it's a product. Sine square 38 into secant square 52. It's a product. See, when you have minus, then you can take the help of the identity. Here it is sine square 38 into secant square 52. So you cannot think of the identity here. Sine square theta plus cos square theta is 1. No, that will not help you. It's a product. So what we'll do, we'll write, change any, always, when you're working with a pair like this. See, here also we work with a pair. Two ratios. You're working with 2 ratios. Whenever you're working with a pair, don't change both. You can change any one of the two. Change any one of the two. That's the idea. Don't change both. So here also, you're working with sine square 38 and secant square 52. Don't change both. Change any one using complementary ratios. So maybe you can write sine square, any one you can change, children. See, in the answer slide, I don't know what I've changed. I'm saying you can change anything. So supposing you change sine square 38. So change using what can we change? So sine square 38 degrees. So you know that sine theta is equal to cos 90 minus theta. You should use this to write it in a different way. So sine square theta is cos square 90 minus theta. So sine square 38 degrees is cos square 90 minus 38 degrees. So sine square 38 is cos square 90 minus 38. So what will you get on subtracting cos square 52 you'll get. When you subtract, you'll get 52. So what happens to sine square 38? Sine square 38 is nothing but cos square 52. This is nothing. Sine square 38 is nothing but cos square 52. Cos square 52. Now what you have? You have changed this, no? You have changed this. You have changed the sine square 38 to cos square 52. Cos square 52. Then you have secant square 52. So next what you can do, you can write cos square 52 as 1 by secant square 52 because cos and secant are reciprocal ratios. Cos and secant are reciprocal ratios. So you can write cos square 52. Using the concept of reciprocal ratios, you can write cos square 52. See here, cos theta is equal to 1 by secant theta. When you square on both the sides, cos theta the whole square is equal to 1 by secant theta the whole square. So cos square theta is equal to 1 by secant square theta. Cos square. Similarly, you can cube on both the sides. You can cube on both the sides. Cos cube theta is equal to 1 by sine cube theta. So you can write cos square 52 degrees as 1 by secant square 52 into secant square 52. So they'll get cancelled. They'll get cancelled. So here identity, here also identity. Here we change either this or this using complementary ratios. Then we also take help of the reciprocal ratios to cancel out them. This one is a standard angle. Yeah, please write down, children. You should be able to understand as you write. Please write down. Just a second. Okay, maybe after this I'll ask you. Lower your hands, all of you. All of you lower your hands. Thank you. Yeah, please write. You're not blindly copying. As you write, please understand what you're writing. Now you have all the concepts in the paper beside you. Look into the paper. Why tan cot square 36 is tan square 90 minus 36? Because cot theta is tan 90 minus theta and cot square theta is tan square 90 minus theta. Done, children?
1 minute, ma'am.
Okay. Yeah. Yes, children, I think You should have completed by now.
1 second, ma'am.
Okay. No. Why is it taking this long?
Yes, ma'am. Completed, ma'am.
Yeah.
Completed.
Yeah, lower your hands, class. Priyanka and Netra, lower your hands. Netra, lower your hand. Okay, children, now very sincerely let me know how many of you following clearly. See, you may not be able to remember because only if you practice you can remember. But as I'm explaining, are things clear to you? Is it making sense? Are you finding it comfortable? Be very, very honest. Raise your hands only if you're following clearly. And if not, I want the reason. If the problem is on my side, or is it because you don't have the introduction clearly? Be very honest.
Ma'am, when you're solving the problems, I can understand, ma'am. But when I try to do a similar problem on my own, I'm not able to do it, ma'am.
No, 1 minute. What is meant by a similar problem? Same problem or similar problem?
Similar kind of problem, ma'am. I get
No,
confused.
you must practice the same thing. Whatever is been explained in the session, you must see it's about practicing the same things, the known things many times. You should not try something unknown when you have not practiced what you know. That's how it goes. That's how it is. See, when the teacher explains something in school, you need to practice the same at home, not similar ones. Practice the same. That's how we all learned. We studied only from the classwork. The teacher used to teach us different things in the class, and we used only the classwork. That was the only source of knowledge for us. We did not have internet. We did not have reference books. We had nothing. Just the teacher who was our guru. And we just went by the teacher's notes and whatever the teacher, did as classwork and gave us as homework. We practiced only that time and again.
Okay.
And all the scholars of this generation and earlier generation have all come up like that. So it's not about the school teacher teaches you something. I know that. Then the tuition teacher teaches you something. Okay, I understood that also. Now I'm going to, get something from the internet or might something from somewhere, which, you're going to work for the first time. You're going to try that. You're just neglecting what the teachers taught you in school and, whatever we learn in the class here. Because what we feel is, okay, I understood in the session. You understood, but do you remember? No, we can't remember like that. What you understand, you will forget in 2-3 days time. Only when you put that to practice, only when you practice them, you should practice the same thing. So you remember, only when you practice, you can retain it in your memory. And only that retention helps you to do your exam well. Retention is very important. When you look at something, it should immediately occur to you that this is to be handled like this. But when you do many things once, it's about working, like 20 problems 3 times. You have selected questions, 20 questions, you work it 3 times. You will remember all the 20. And using the knowledge and the concepts you've understood through those 20 sums, you can crack some 21st sum, which was not worked by you, which is new. But using the concepts which you've understood very clearly through these 20 sums, you can crack the 21st sum. But if we work some, 100 questions once, 100 questions you have solved. I have solved 20 questions 3 times. Same 20 questions 3 times I've solved. So I remember all the 20. And I know the difference between the second answer and the 20th answer. I know the difference between the 11th answer and the 8th answer. I know when the question is like the 11th one, it is to be worked like that. When it's like the 8th one, it's to be worked in a different way. I know the difference between the different questions and the way they have to be answered. I've mastered all the 20 questions. So the 21st question, I can handle it smartly using the knowledge and the concepts I've learned through these 20 questions. But when I work 100 sums once, 100 different sums, only once I work it, nothing I can retain. When I work, as I work each and every sum, I will remember, I'll understand. And it'll be like, it'll seem like as if you can remember all of them. Because when you work that particular sum, you understand that when you keep moving ahead, when you come to the 50th sum, the first second will be forgotten. Because you worked it only once. So when you finish all the 100 sums, after 2 days, all the 100 will be out of your mind. So some 101st sum in the exam, it look easy, but you will not be able to, work it correctly because nothing is clear to you. You worked everything just once. You're not able to recall anything clearly. You're getting things in bits and pieces. You're not able to complete anything correctly. But that person who's worked 20 sums 3 times will be able to do that question. So whatever you learn must be clear. For that, you should work the same thing, not similar things. Same thing many times. Please believe me. Work, just follow your teachers, your school class work and the tuition notebook here. Do not use any other material to refer. Work the same sum from the tuition notebook. Work the same thing. Practice the same thing 2-3 times. And you will see the difference. You please try it once. You please try it once. And when you see the difference, when you feel the difference, then you will believe in it. This is for the class. I'm not talking to Priyanka. This is for the class. And that's how it goes. Use the school classwork notebook. Practice what your teachers taught you in the school. Use this notebook, the tuition notebook. Practice whatever you understand in the class here. That's enough. Master these sums. Master these sums. Once you think you've mastered them, you can then check how well you've understood using, some other set of questions. Yes, Priyanka, please work the same sum, the same sums from the classwork, Priyanka. All right. Okay. And at the end of trigonometry, we'll see how you feel. Now, for now, what you if you've learned trigonometry in school, work out, practice what your teachers taught you. If you've not still learned it in school, then it's only the tuition notebook. Work the same thing from the tuition notebook as many times as you can. Whenever you find time to practice maths, work the same sums. Master these, answers. At the end of trigonometry, when we revise, you will be able to crack a different sum, which we have not solved in the class here. You will be able to get the idea as to how to solve it correctly. You can take it as a challenge. You will see that in yourself. All right?
Yes, ma'am.
Yeah. So, okay, so you all raised your hand to say that you understand what was being taught in the class. What about Netra's new? What about Murali Krishna? Okay. All right. Fine, Chitu. Let's go ahead. So you can see here we have used the concept of complementary ratios. Complementary ratios. Then here, trigonometric identity, secant square theta minus tan square theta is 1. Similarly, here in the denominator, complementary ratio. Then this one is cosecant square theta minus cot square theta, which is 1. And from secant square 52, we get cosecant square 90 minus 52, complementary ratio. Then we write cosecant square 38 degrees as 1 by sine square 38, because cosecant square theta is 1 by sine square theta. Cosecant and sine are reciprocal ratios. So cosecant square 38 degrees can be written as 1 by sine square 38. See, this one becomes 1. This is 1 by 1. Here 2 into sine square 38 into cosecant square 38 is 1 by sine square 38. See here, sine theta is equal to 1 by cosecant theta. So when you square on both the sides, sine square theta is equal to 1 by cosecant square theta. Sine cubed theta is 1 by cosecant cubed theta. Cubing on both the sides. Yeah, and the value of sine 45 is 1 by root 2. So sine square 45 is 1 by root 2 the whole square. And then it's just simplification. Yeah. Now, what do you think should be the answer for this, children? What should be the answer when you work? You need to find sine square b plus cos square b. What do you think the answer should be? From the figure, find sine square b plus cos square b. What do you think the answer should be? Look into the algebraic identities, all of you. What is sine square theta plus cos square theta? Am I audible? 1. Sine square theta plus cos square theta is 1. So what should be the value of sine square b plus cos square b?
One, ma'am.
1.
1, ma'am.
1. Sine square b, see, sine square theta plus cos square theta, that is same angle, theta, theta. Here also sine square b plus cos square b is 1, should be 1. It should be, you should get the answer as 1. And what do you think should be the answer for this one? Secant square c minus tan square c?
1, ma'am.
Yeah, why? What is the identity?
Secant square theta
Secant.
minus
No.
secant square theta minus tan square theta is equal to 1.
Is equal to 1. So secant square theta minus tan square theta is equal to 1. So secant square c minus tan square c should be 1. So you know the answer, but you have to work. So both the expressions, the value is 1. The value is 1. So this is about angle B, children. Angle B is in the right triangle ABD. Angle B is in the right triangle ABD. Angle C is in the right triangle ABC. So two different right triangles. For angle B, you should use this triangle. For angle C, you must use this right triangle. You should not use the whole triangle for anything. You can use only a right triangle. So use this right triangle for angle B. This right triangle for angle B. And use this right triangle for angle C. You must use only a right triangle. So you know that you need to know the lengths of all the three sides. So use Pythagoras theorem, and this is 4, this is 3. So find the hypotenuse. And this is 4, this is 6. Use Pythagoras theorem, find this hypotenuse. And then find, how will you find sine B? What is sine B? Opposite by hypotenuse. What is sine B? Sine B connects the side opposite to angle B by hypotenuse. See, how do you mark off the opposite and adjacent sides with respect to the acute angle? With respect to angle B, this is the opposite side. this is the adjacent side. For angle B, this is the opposite side, this is the adjacent side. This is the hypotenuse because it's opposite of the right angle. And for angle C, you should see within this triangle, in this right triangle, for angle C, this is the opposite side and this is the adjacent side. And opposite of the right angle, this is the hypotenuse. Yes, that's all. I'm not explaining this further. Work this. You can go through first and then start working, or you can start working and try to understand as you work. I've taken this triangle separately. That whole, oh, you need to take the question. Children, please take the question. Please take the question, children. Sorry. Yes, I think all of you must have copied the question by now.
Yes, ma'am.
Okay. Yeah. Why is sine B 4 by 5?
Opposite by hypotenuse.
Opposite by hypotenuse. So 4 by 5. Very good. You can also write sine B is equal to AD by AB. You can also write that. Sine B is equal to opposite AD by hypotenuse AB. You can, if you want to include that, sine B is equal to, you can write it like this everywhere. Sine B is equal to opposite AD by hypotenuse AB. That is why it is 4 by 5. Similarly, you can write for cos and all the other ratios. You can mention the sides. You can mention the sides using the ratio. So since we have to find the value of sine square b plus cos square b, we find the value of sine b and cos b from the right triangle. And then we substitute. When we work, we get 1. Similarly, from the other triangle, we find secant c and tan c. Why? Because we have to find secant square c minus tan square c. So we find secant c and tan c. And then we work secant square c minus tan square c. We work that and we get 1. You should get 1. We know that we must get 1. Very simple this is. Finished writing, children?
Yes, ma'am.
Okay.
Completed, ma'am.
Very good. Isn't it easy, children? You must use the relevant right triangle. Important is you should use the right triangle. And for sine B and cos B, you must use the right triangle which has angle B. And for secant C and tan C, to find secant C and tan C, you must use the right triangle which has C, angle C. So see here, so I've cut this triangle into 2 right triangles. We use, this one for angle B and this right triangle for angle C. That's what you see here, 2 separate triangles. First, find the hypotenuse using Pythagoras theorem. And then find whatever ratios you need. Sin B cos B to find sin square B plus cos square B. Secant C tan C to find secant square C minus tan square C. Okay, next one. If 16 cot A is equal to 12, find sin A plus cos A by sin A minus cos A. So again, in this, through this answer, we'll see how we can make use of the given ratio itself to evaluate this. This we cannot do everywhere, only for certain, situations. So we'll see how we can use the given t ratio itself to evaluate this. See, normally what we do when 16 cot A is equal to 12, that means cot A is equal to what? What is cot A? What is cot A?
1/10.
What is cot A? No, I don't know if you people are lazy. Oh, I still don't understand. What is the value of cot A? What is the value of cot A, children? You're all eating, is it? So you don't, your hands are not free to unmute and your mouth is full. You're not able to talk. Huh? Even I'm hungry. What's the answer? What is cot A?
Sin A by cos A, ma'am.
That's not what I'm expecting. See what is given. 16 cot A is equal to 12. From this, what is cot A?
12 by 16, ma'am.
12 by 16. What do you mean by 16 cot A is equal to 12? I told you this is 16 into cot A. That's the meaning. 16 into cot A is equal to 12. 16 into cot A is equal to 12. That's the meaning. So cot A is equal to 12 by 16, which can be reduced to how much? 4, oh, sorry, 3 by 4. 4 3s are 4 4s are 3 by 4. Now all of you understand? It's okay if you're eating. You just say yes. Yes or no?
Yes, ma'am.
Yeah. So cot A is equal to 3 by 4. Now next, what should you do? Normally what we do, we take up a right triangle and we, fill these values 3 and 4, and we find the missing side, and then we'll find the value of sin A and cos A and evaluate this. Now without that, without finding sin A and cos A, using 16 cot A is equal to 12. 16 cot A is equal to 12. So cot A is equal to 12 by 16. There are many ways of doing this. So cot A is equal to 3 by 4. Cot A is equal to 3 by 4. I've done how many methods? Okay, I've done all the 3 methods. Fine. So let me explain using the slide itself. So see, children, this is the first method. Concentrate on what I'm explaining. Cot A is equal to 3 by 4. Now we'll use, how do you get cot A? Now we need to evaluate sin A plus cos A by sin A minus cos A. Sin A plus cos A by sin A minus cos A. Write down what you have to evaluate. Sin A plus cos A by sin A minus cos A. Divide both the numerator and denominator by sin A. That's what you see here. Dividing both the numerator and denominator by sin A. See, you need to evaluate this one. Divide both the numerator and denominator by sin A. Now you will wonder, how can you divide like that? That's what we always do. That's what we always do. Now look at this. Now children, 16 cot A is equal to 12. Now cot A is equal to 12 by 16. Now how did we get 3 by 4? How did we get 3 by 4? Because we divided the numerator by 4 and the denominator by 4. How did we get 3 by 4? Because we divide the numerator by 4 and the denominator also by 4. Because we divide the numerator by 4 and the denominator by 4. So that gives us 12 by 4 is 3 and 16 by 4 is 4. So you can divide. You can divide both. What you should do is you should do the same thing to the numerator and the denominator. So you divide the numerator by 4, the denominator also by 4. Similarly, what you do is you take up the expression to be evaluated and you divide the numerator and the denominator by sin A. By sin A. So what will you get? What is sin A by sin A? 1. What is cos A by sin A? Cot A. Here, when you divide both the numerator and denominator by sin A, what is sin A by sin A? 1. Cos A by sin A, cot A. Then the denominator, sin A by sin A, 1. Cos A by sin A, cot A. So now we have 1 plus cot A by 1 minus cot A. What's the value of cot A? 3 by 4. Cot A is 3 by 4. So 1 plus 3 by 4 by 1 minus 3 by 4. LCM, and you get 7. You get 7. Otherwise, what you can do is, if cot A is 3 by 4, since cot A is 3 by 4, you can find tan A. Tan A is 4 by 3. If cot A is 3 by 4, tan A is 4 by 3. Don't write, children, just listen. You can write in the next class. So since tan A, cot A is 3 by 4, tan A is 4 by 3. So you can also divide the numerator and denominator by cos A. Here you divide by sin A, right? You can also divide by cos A. What do you get when you divide by cos A? Sin A by cos A, sin A divided by cos A, tan A. Cos A by cos A, 1. See, that's how you simplify. Sin A plus cos A, the whole thing by cos A means what? How do you simplify this further? It's sin A by cos A, sin A by cos A plus cos A by cos A. So sin A by cos A is tan A plus 1. Tan A plus 1 divided by sin A by cos A is tan A. Cos A by cos A is 1 minus 1. Now we know the value of tan A, 4 by 3. So 4 by 3 plus 1, 4 by 3 minus 1, LCM, and you can see that we get the same answer, 7. Otherwise, the usual procedure. There's actually one more method. I'll modify the slide and show you in the next class. So you don't write now. You can write on in the next class. I'll just include one more method, and you can write all the 4 methods in the next class. So the other method is familiar to you, because what we've understood is when we are given the value of one t ratio, we can find the other t ratio using a right triangle. The regular procedure. Use a right triangle. Find the missing side using Pythagoras theorem, and find sin A and cos A. Sin A and cos A. Find sin A and cos A and substitute the values. Sin A and cos A. Substitute the values and evaluate. 7. Whatever method you use, the answer is 7. The last method is what we normally do. When we are given the value of one t ratio, you can find the others using a right triangle. So that's the idea here in this method. In this method 2 and method 1, what we do is we divide the numerator and denominator either by sin A or cos A. So when you divide by sin A, you get cot A. When you divide by cos A, you're getting tan A. So what is cot A? 3 by 4. Use that value. If you're getting tan A, cot A is 3 by 4. So tan A is the reciprocal, 4 by 3. In all the cases, the answer is 7. You should get the same answer. All right, children, you can write this in the next class. Fine, children. So that's it for today's session. Thank you so much. You may leave the call. Netra alone, if you're there, please stay back. Yeah, others may leave the call. Thank you.
Thank you, ma'am.
Thank you, children. Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.